There you go. Now, happy Friday to you guys. There we go. We have to do a do-over on that. So just real quick here, a few housekeeping items just so we're set on the same page here. So you guys took a test. How was the test? Raise hands, it was easy. Let's do that. Raise hands, it was easy. Raise hands, it was medium. It was like, hey, it's good. It's good. It tested what I needed to test. It was good. Okay. And then hands down, and then raise your hand like I was lost. Have no clue still what that test was about. Okay, everybody's in the middle. That's a good thing. Okay, next. So I'll grade them, and I don't know what Abe did because Abe probably did something funny over there. Let's go with. I'll be grading the tests sometime before Christmas. I also sent a lot of you guys, if you are missing any work on Google Classroom, I sent that to you guys. If you get an email from me with missing work, please do so, because when I grade those exams, what I'll do is I'll start putting in zeros for any missing work after that as well. So if you have any missing work, turn it in Monday, Tuesday-ish or something like that, because then I'll get exams and I'll start grading. So be mindful of that. I do want to catch up on all the grading. Winter break, so when we come back in January, everybody knows their grade, and we're sort of finishing up the semester because it'll be a little month for us to finish up the semester. Okay, any questions from you guys? I just want to make sure. Going once, going twice. Speak now or forever hold your peace. Yes, Camille, go ahead. Say that again.
Are you going to give us any homework?
Yes, what I'll do is right after this lecture, I did it yesterday. I did the homework sheet yesterday. Everybody's like, what, Camille? Why did you say that? No, I already had it planned anyways. It's already printed out on my little Adobe sheet. I was just going to do this section with you first and then send it out. So after this class is over, I'll send out a little homework sheet for you guys. It will have the rest of all chapter 1. So it actually will have chapter 1.6, 1.7, 1.8, 1.9, and 1.10. It'll have the rest of homework for chapter 1. In case you're bored during Christmas break and like, I really want to do some Algebra 2 homework, go ahead. You have all the means for it. Anybody planning to do that? Maybe? No. Okay. I figured as much. Okay, so let me do this here. Let me stop sharing my video. I'm going to start sharing my screen only. And are we good there with the screen? We're going to try to get through 1.6 today. And we are doing something called parent functions. Parent functions, I call them mama and papa functions. There it is. It's going to be some funny stuff. So tell me if you guys have everything correct. Landon, thanks so much for fixing whatever it is you're fixing over there. Is it the volume or just the screen itself? Okay. So let's jam. Let me get my notes here. So this is 1.6. We finished up with 1.5. And we go with this guy, 1.6. Sorry, just getting my notes on this side here. Okay, it's called a library. You guys thought libraries were all the same. No, this is something called a library of parent functions. Okay, super duper important because we need to know we're kind of coming to the tail end of all the graphs from Algebra 1. We want to be able to sort of categorize them. So this is the end. This is the pyramid, end of the pyramid for us as far as all these different functions you've learned in Algebra 1. And now we're going to just write them all down because this is what we need. Okay, so we're going to have a graph of it, and then we're going to take a look at a few things that are needed for us to know. And we're just going to go through it. So 1.6 is a quick review of all the functions we should know. 1.7 then is we're going to start changing them. So I say, okay, if that's the parent function, then let me change it. And let me see how I can move things around to model things here. So 1.6, here we go. So first things first, I'm going to introduce a function. We're going to look at its domain range. We're going to see if it's even, odd, or neither. I'll let you guys copy those down. Are there any x-intercepts? Are there any y-intercepts? When is this function increasing, decreasing, or constant? And then is there any minimum or maximum values here? So first function, let's go with it here. So we have 1, 2, let me count them here. 1, 2, 3, 4, 5, 6, 7, 8. 8 functions we're gonna put together here. So first things first, this guy's called the constant function, which means the function is exactly the same no matter where you slice it. It's just going to be just like that. So constant function is usually just a single number. So the equation is like this. It's y is equal to, and we just call it b. And let me just graph b. I'm going to use E2 kind of like b, but it's like this right here. It's going to be a horizontal line straight across. This is the basic function. Like that. I just use 2 as an example. And so let's jam with it here. So what's the domain of our constant function? It's going to be from negative infinity to positive infinity. It's going to be the same all the way through. I can plug in any x I want, and it's going to be that function itself. Okay, so then the next question is, what's my range? Notice this guy, it's one single thing. It's just b. I was using an example of 2, but then we should kind of just sort of see. There it is. That's it. Just single value is the range. Question comes up, and you guys talk to me here. Does this have y-axis symmetry? Is it even? Does it have symmetry about the origin? Or is it neither? Yeah, it's even. We can even circle it, or we can just say even at the end. This is an even function because anything in quadrant 1 reflects back. If you were to fold this right across the y-axis, the 2 graphs will fold right on top of each other. Cool. Okay, and then again, we're going to go through these a little faster each time. And once we use these parent functions here, and we start moving them around, which is in 1.7, then we can actually start modeling things in real life, like how a ball bounces. That's cool. Or certain cost function of a business can be modeled once we realize which function do we want to use and how do we want to move it around. Okay, any x-intercepts? Only if b equals 0. Right, if b is equal to 0, then it goes right along the x-axis, then everything is an x-intercept. Otherwise, it's above. Any y-intercepts? Yes. Y equals b. In this case, it's 2. And of course, increasing none, decreasing none, constant, yes, from negative infinity to positive infinity. That's why it's called a constant function. All right, and do we really talk about minimum and maximums on this? No. So on a constant function, because the minimum and the maximum are the same even, so there's none there. Okay, are we good? Do you guys remember this? Or just dealing with constant functions? Remember in Algebra 1, you guys graphed something like y equals 3, or y equals 7, or y equals -2. That was just a constant function. Okay, you guys tell me if you are ready to go on to the next one. Or tell me if you're not ready. So I'm going to go with this. Constant function, done. 1 is done. 1 done, 7 to go. Maybe 8. I think I may introduce you to another one. We'll see. Okay, boom. Let's jam. Next one. Same exact setup, same exact graph here. We're going to call this the identity function. Very important, especially when we look at something called inverse functions later on. Identity function just means this: y and x are exactly the same. So y equals x. You know what we should do? We should actually write this in function notation. So let's do this here. So you can write it like this, or you can write it as f of x is equal to x. There you go. There's your two different ways of writing it. On our constant function, let's go back real quickly here. Constant function. I don't know why they do this in mathematics, but what they do is they do this here. They just write C for constant. So whenever you see a C, that usually just means constant. For an x and y graph, vertical lines are x equals a, horizontal lines are y equals b, but for a constant, it's f of x equals c. Okay, let's jam back to this guy here. Boom, identity function, here it is, f of x equals to x. So can you guys graph a graph where the x's and y's are exactly the same? So 0, 0 would be a good point. 1, 1 would be a good point. 2, 2 would be a good point. So here's our identity function. 0, 0, 1, 1, 2, 2, 3, 3. And you can see what's happening here. It's a diagonal line coming through the origin. And then also the other way too. So there's our, and then little arrows at the end because it keeps on going. Okay, domain. Domain is from negative infinity, positive infinity. I can plug in whatever I want for x, and it'll give me a value for y. Talk to me. What's my range for this guy? Along the y values, can I go way, way, way low for the y values? Yeah, I can go on forever going down, right? It'll go forever down. Does it go forever up along the y values? Absolutely. So range is, again, it goes both ways here. Even, odd, or neither. So even, it flips it across the x-axis, right? The odd flips it across, flips it across the y-axis. The odd numbers, they go from quadrant 1 into quadrant 3. So it's flip along the y-axis and the x-axis at the same time. So notice real quick, you have this. You have 3, 3. And down here, you have a negative 3, negative 3. Notice the x's are switched signs and the y's are switched signs. So this guy is an odd function. And let me jump back real quick here just to show you on the constant function right here. So notice this guy here. This was what? This would be like 3, 3, 2. When you jump over here, you get a negative 3, 2. So notice only the x value switches. The y value is exactly the same. That's what makes an even function. Odd function, both signs switch. Negative 3 become a positive 3, positive 3. Any x-intercepts? Yes. X is equal to 0. Y-intercept? Yes, it's at the origin, so y is equal to 0. When is this guy increasing? He is increasing from negative infinity to positive infinity. He's always increasing. And then decreasing? No, because if you look from left to right, like we normally read a book, notice this graph is going up a hill. So is it ever constant? No. Do we ever talk about minimum and maximum values for this guy? No, because it goes down forever, up forever. Okay, identity function. Are we good? Mm-hmm. And this is the not so fun part of doing these graphs. When we actually get into modeling things, you may find some of these graphs pretty fun. We'll see. We'll get to 2 last ones that will be kind of interesting. Okay, so let's see where we're at. 25 minutes to go here. I'm going to see if we can get most of these done, if not all of them. Okay, you jam. You guys tell me if I'm going too fast, okay? Next. linear functions. Now you guys know these guys here. Linear functions. Y is equal to mx plus b. That's one way of writing it. Or the other way of writing it is f of x is equal to mx plus b. So this one, I'm going to have to just kind of draw a regular O graph. Yours may not look exactly the same as mine here, but I'm going to just kind of plot two dots here, just arbitrarily. I'm going to say, okay, that's a linear function. Kind of goes like this. I just want it not go through 0, 0. I want it to be a little bit of a diagonal-ish kind of line with a little bit of a slope, and that's just an example right there, right? But the equation for it would be any kind of m value plus a b value. Okay, the linear function. This is cool though, because we arrive like at the height of the pyramid. We're just reviewing all the different functions we've learned so far. Domain, negative infinity to positive infinity. Any x will give us any y. Range. Notice it's very similar to the identity function. Okay, this guy, even, odd, or neither. Yeah, in this case, it's not, yeah, it's neither. There's not a specific thing there. Okay, a little tougher one. Are there any x-intercepts here? Yeah, and this is a tough one here because there's no really formula for intercepts here except for the y-intercept. So are there x-intercepts? Yes. We'll just put yes because there's different ways of finding the x-intercept. The y-intercept is actually pretty steady. This one is just y is equal to b. We know that from graphing lines. Okay, does this increase, decrease, or constant? Well, it's increasing only if m is greater than 0, right? If m is positive, if the slope is positive, it will be increasing. If the slope is negative, it will be decreasing. And then it turns into a constant function. It turns into a constant function if m is equal to 0. We talk about minimum maximum values? No. We don't really talk about minimum maximum for this one. There's our linear function. Again, we've been doing this in algebra ever since we first started graphing, but this is our function. And this is the way we think about algebra, really. We think about everything as in terms of functions. So what kind of function you have, and that's what we work with. Okay, let's get into some funner ones. Again, 1.6, the boring side. 1.7 is going to be a little bit more of the funner side of this. 1.9, when we start modeling, that's actually, no, let's see, 1.10, when we start modeling things, that'll be more fun. Okay, linear function. Next one. I think you guys know this one here. This guy is called the quadratic function. All right, what's the formula for it? Y is equal to x squared, or f of x is equal to x squared. All right, can you guys graph this one for me from Algebra 1? Do you know what the graph of this looks like? All yours on our sheet of graph paper here. See if you guys still remember this one here. I think it's 0, 0, 1, 1. Then you take 2 and you square it, becomes 4. Take 3, square it, becomes 9, and that's already off my chart. -1 times -1 is +1. -2 times -2 is +4. So it looks like this right here. It comes down. And make sure you just kind of curve it at the end. Don't make it a V shape. It should be a U shape. It just kind of curves. There it is. There's my x squared function. You guys remember that one from algebra 1. All right, domain is negative infinity to positive infinity. I can plug in whatever x I want. I just square the number and I get my y value for it. All right, what's my range? Notice it doesn't go below 0. 0 is the lowest point this guy will ever have. So in this case, we say that the range is from 0 to positive infinity. All right, talk to me. Even, odd, or neither? It's an even function. Okay. Yeah, but you could tell. Just by their x-intercepts for this guy, yes. X is equal to 0. Y is equal to 0. Let's see. When is this guy increasing? This guy is increasing from anything that's higher than 0. Notice the graph is going up. On the right-hand side, it's decreasing all the time from negative infinity all the way to 0, and then that's when it changes. Constant, none. It is never constant. Do we have a maximum or a minimum value? Yes, we have a minimum value at 0, 0. All right, 1, 2, 3. You got 4 done, halfway there. All right, thank you guys. I know this is a little bit of it's just almost tedious a little bit here, but we do have to have our understanding of each one of these guys. Okay, next on the list, that's x squared. Again, tell me if you need more time. So we got the quadratic function. Now let's jump to the cubic function. Now y is equal to x cubed, or how about f of x is equal to x cubed? All right, graph it if you know how to graph it. If you still remember it from algebra 1. Let's see, I have a friend that teaches calculus, several friends that teach calculus here at Fresno State. But what he does, this is the first day of class. What they do is they repeat all these functions right here. You say, okay, they literally do this lecture right here, and then they say, okay, now let's start manipulating these functions, and they go with it here. And you have a whole branch of calculus that starts off, whole branch of mathematics. And it's okay, so talk to me here. I think this is 0, 0. If you take 1 and you go 1 times 1 times 1, it gives you a 1, is that right? 2 times 2 times 2. 8, I heard, yeah. And this is off my little chart, but I'm at 7, so I'm going to plot 8 right here. I'm going to plot the little 8 here. And then going the other way here, negative times a negative times a negative, or negative 1 times negative 1 times negative 1. And then negative 2 times negative 2 times negative 2 would put me about right there. So this little function goes like this, hits here, almost going straight up, and then it kind of turns like this. It curves, and then it curves this way. Oh, I drew my dot in a little different spot here. There. Okay, that's my x to the third function. So as far as domain is concerned, here it is, negative infinity to positive infinity. I can plug in whatever x I want. I just take that number and multiply itself 3 times, and I get my y value. My range, is there a low value for my range? No way. It goes all the way down to negative infinity, goes all the way up to positive infinity. Everything is there. I will say your book sometimes, let's mention it right here. Your book sometimes, whenever it goes from negative infinity to positive infinity, sometimes it'll just say all real numbers. It'll say that, but those two really mean the exact same thing. If you say all real numbers, you usually mean from negative infinity to positive infinity. Okay, even, odd, or neither, go. I think I'm going to go with odd. Yeah, so notice right over here, let's say if we pick on 2, 8 right over here, and then we go down here, this becomes -2, -8. So whenever you change the sign on your x value, the sign on your y value also changes. That's what makes it an odd function. All right, x-intercept, yes, 0. Y-intercept, 0, because it's at 0, 0. Increasing all the time. It increases from negative infinity to positive infinity. Does it ever go down? No. Is it ever a constant? No. Is there a minimum or maximum to this? No, there's none. Okay, cubic function. Done. Okay. Almost there, guys. Almost there. Okay, cubic function. Next one is going to be, we'll call it the square root function here. Square root. All right, square root function. Let's go. Y is equal to the square root of x. There it is. Or f of x is equal to the square root of x. And this one, kind of remember that, let's see, we can't put negative values in for x, is that right? Because there's no way you can get a -4 out of this. So in this case, all the values have to be positive. And so if we want to, we make a little table even. We'll put an x, we'll put a square root of x. So if I do 0, square root of 0 is 0. Square root of 1 is 1. And if I put 4 in here, the 4 I think is the best to do that with here. Square root of 4 would be 2. Everybody okay with that? So we're taking the square root of that function. So square root function goes like this: 0, 0, 1, 1, 4, 2. And then I know the next one's going to be, anybody, what's the next dot going to be? Yeah, 9 and 3, huh? So it's off my little chart here. So I'm going to kind of bend this out like this and then kind of come a little closer to 3, but not quite, with a little arrow there. Ooh, we have our first domain problem. So notice there's no negative values we have. So domain is going to be, are we including the 0? Is 0 part of our domain? Yeah, we can get a 0, right? We can plug in 0, square root of 0. Yeah, we can't plug in square root of -1. So our domain are like this. It's going to be the bracket at 0, then off to positive infinity. Okay, anybody for range? What's my range here? Let me turn on my speaker louder as well here so I can hear you guys. Anybody want to take a try at the range? Yep, perfect. It's the same thing. So if you're talking about this space right here, 0 is the lowest one, and we do get a 0. And it goes off to positive infinity. There it is. All right, even, odd, or neither? Yeah, it's neither. Yep, in fact, it's only in quadrant 1. That's the only time we see it here. X-intercepts, yes, 0. Y-intercept, 0, because it's both at 0, 0. Increasing, yes, it is increasing forever. It goes up higher and higher. Does it ever go down? Nope. Does it ever become a constant? Nope. And the minimum to this, yeah, there's a minimum. So minimum at 0, 0. There it is. Okay, let's see. Let's see if we get through the next two really quick here. Squared function is done. There it is. Again, one of those functions we're going to start moving around eventually. Where do we model this stuff? Usually we model this using, or we model this of comets, asteroids, meteorites, anything that has a curve to it. Stopping distance of a car usually is that way too. When you slam the brakes on a car, we have stopping distance that is measured this way. Inversely, going the other way. So we'll see how we can flip that around sometimes. Okay, let's go square root function. Next one, go a little bit faster. Something called the reciprocal function. And reciprocal function, all it does is changes the numerator and denominator. It's the 1 over x. Take an x value and you flip it around, becomes the reciprocal function. So if we want to, we can make a little table here. If you just say the reciprocal of 1 is 1. The reciprocal of 2 is 1/2. The reciprocal of 3, plug a 3 into there, becomes a 1/3, 1/4, 1/5. So notice, oh, that's cool. It goes like that. But then how about if we take a reciprocal of 1/2? Talk to me. Reciprocal of 1/2. It's 2, so it goes this way. Reciprocal of 1/3 would be 3, so you got this little graph that goes like this. It comes down very close to the y-axis, and then it kind of turns, and then it bends, and then it gets really, really, really close to the x-axis as it goes out. Very close, just doesn't touch. So real quick here, can I take reciprocals of negative numbers? What's the reciprocal of -1? -1. Reciprocal of -1/2. Oh, -2 is -1/2. So reciprocal of -3. So hold on, we got the same thing happening on this side. Again, just kind of hugs the x-axis. Reciprocal of -1/2 is a 2. Reciprocal of -1/3 is a 3. And it goes this way as well. And it kind of hugs the y-axis on the way out. Okay, raise your hand if you saw this in Algebra 1 before. Like, oh yeah, I remember this function. I remember graphing something that looks like this. No, okay, so this is a new one. Okay, that's cool. Okay, okay, that's cool. Good to know for me as well. So the domain is kind of funny on this one. Notice the domain is all the numbers work except for which one? Which one you can't take reciprocal of? 0. That's right. So here it is. We're going to go like this. We're going to go from -infinity. We can take any numbers way, way to the left of this graph, and we go up to 0, and we're going to put a little parenthesis around 0 because saying, look, I'm not including the 0. Then what I do is I put this little U for union. It's kind of like a capital U. So all the numbers work from -infinity up to, but not including 0, and then anything after 0 works, and it's just perfectly fine. Just not the 0.
All real numbers except for 0?
Yes, perfect. Okay, so another way to do it, even though the book doesn't write it this way here, you can say all real numbers. Chicken scratch, hold on. All real numbers except x is equal to 0. There's another way of saying it. Okay, the range, as you look up, this is the way I usually do range. I start looking this way. I look, okay, if I'm looking this way, is there any value that's not listed here? Notice that little line never touches the x-axis, right? So in this case, it's the same thing. It goes from -infinity up to 0, breaks at 0. Then it goes off to +infinity And let me erase this so this doesn't look weird again. Boom. All right, even, odd, or neither. All yours for that one. Odd, perfect. Yes, I totally agree. So let's pick on a little problem here. This one right here, 2 comma 1/2. So the question is, can I find its opposite anywhere? Yeah, find its opposite right here, -2 comma -1/2. Right there, this guy's an odd function. X-intercepts, none, because it never touches the X-axis. Y-intercepts, none, never touches the Y-axis either. Ooh, this was a fun one. Increasing, decreasing, or constant? It's going down all the time, isn't it? Right, it's slowly going down in the negatives, right? And then it goes whoosh, really goes down. So increasing, none. Decreasing, yes, from -infinity to 0. All this time it's decreasing. Okay, and then we got to get this union again, and then from 0 to +infinity. So all the time, all the X values when this guy's going down. Constant, none. Any minimum or maximums? None. There's no minimum maximum here. Okay. I think we have time for one more function, and we didn't get to all of them here. One more function, which you recognize, and then we'll deal with probably two. Let's see. Yeah, let's do one more here. One more. We have time for one more. Then we'll introduce something called a step function. I'm pretty sure you haven't seen that before. So reciprocal function, done. Are we good? Thank you guys so much for going through this. I know it's not super exciting, but we do have to go through all of these, and then we'll start using them, which then that'll be kind of cool. All right, absolute value function. I think you guys have seen this one before. It looks like this. In function notation, it looks like this. Let me make that parenthesis a little bit better. All right, there it is. Absolute value function makes everything positive. So if it's positive, it stays the same. If it's negative, changes to positive. Can you guys graph it for me? So 0, 0 stays the same. 1, 1 stays the same because it's already positive. 2, 2, 3, 3, so on and so forth. This is nice. It looks like our identity function initially. But then when we get to the negative side, absolute value of -1 is a positive 1. Absolute value of -2 is a positive 2. Go on, so forth this way. And we have ourselves our V-shaped graph for absolute value. Again, do we use this? Absolutely, we use it. Pun intended. All right, domain. Is there any time where there's a problem plugging in an X value? No, that's just fine. -infinity, +infinity. My range is a little different. What's my lowest value here now? We got ourselves a 0. So 0 to +infinity is my range. Even, odd, or neither. Let's test it. Let's test it. This guy here is a 3, 3. And then over here, we got ourselves a -3. So the X sign, the sign of our X changed, but the sign of Y did not. So this guy is an even function, just like X squared. X-intercepts, yes. 0. Y-intercept, yes. 0. Increasing, yes. It increases on the right side only. So 0 to +infinity is increasing. Decreasing is from -infinity to 0. So all the time here, up until it gets to here. So notice whenever we say increasing, decreasing, we're talking about the X values. Is it ever constant? No. But we do have a minimum at 0, 0. All right, Class, we did not get to the greatest integer function yet. That's the last one that we have to do, and then we'll go from there. So we will revisit this real quick here on Monday, and then we will go over the greatest integer function, and then we'll actually start using it a little bit here, a little bit for these. So I'm going to give you the homework sheet. I'll send it out to you guys just so you guys have it, but you probably don't have enough information to start on things yet. So how about this? Rest for the weekend. We'll be back Monday, and then we'll go from there. Thank you guys so much. Have a good weekend. See you Monday. Thank you, Isabel, so much for spraying down stuff. Bye-bye, Annette. Cool. Thank you, Stella, so much for doing that. Thank you, Isabel, for doing that. Cool. You guys are like tag teaming it here.